Well, it's our pleasure to be hosting our LSU colleagues and friends, Professor Robert Rohli and Professor Carol Friedland from LSU. Our pleasures are going to give us a joint seminar this week, which is wonderful. And I'm going to introduce Bob first. He's going to go first, and then Carol will follow up. So 2 introductions coming your way here. Dr. Rohli is a professor in the Department of Oceanography and Coastal Sciences at LSU and the director of the new Coastal Meteorology program as of this year that he will be talking about primarily in the first part of our talk. He received his Ph.D. at LSU in 1995 under Keith's direction with lots of input from the well-known coastal meteorologist S.A. Sue, and his MS in Atmospheric Sciences at Ohio State with Jeff Rogers, a CU alum, and who actually worked a lot with NCAR scientists here, including Harry Van Loon. Bob also has a textbook, Meteorology for Coastal Scientists with Chunyan Lee, that came out in 2021. And Dr. Carol Friedland is the director of the Lahouse Research and Education Center and professor of biological and agricultural engineering at LSU's Agricultural Center. She is a registered professional engineer in Louisiana, Florida, and Wyoming, her home state, a certified floodplain manager and a fellow of the Structural Engineering Institute of the American Society of Civil Engineers. Prior to joining Lahouse, she was a faculty member in LSU's Construction Management Department since 2009. She holds bachelor's, master's, and PhD degrees in civil engineering. And Carol's also received an AdEC Faculty Innovator Program Award titled Flood Risk Reduction through ASCE 24 and National Water Model Analysis that will start this fall. Last but not least, a large degree, this institutional collaboration that we are so privileged to have was triggered by our PCEF that is just now completing, and that was led by Professor Naz Labusra in the back, who was visiting here under an FCC faculty fellowship program until the end of July. So, Bob, please.
Thank you, Tom, for such a nice introduction. And thanks to all of you here in Boulder for teaching me what summer is supposed to be like. And it's just very nice to be here. I have a happy story for you today. So it's a fun presentation for me. And I enjoy talking about LSU coastal meteorology any chance that I get. So it won't be a technical presentation, but it'll be a lot of good, fun stuff. We actually at LSU have deep roots in coastal meteorology. We just didn't call it that for a long time. Richard Russell, we have a Howell Russell Geosciences Complex at LSU named after him, arrived in 1928, and I think he's still the only person to have served both as the president of the Geological Society of America and the American Association of Geographers. So he was a polymath, I guess you could say. And I think among the things that he was most known for, I think he was either the first, or I can at least say among the first people to use spaghetti maps to depict the idea of climate change, which wasn't all that big of an idea in his time, to show changing climate classification systems across space and time and that sort of thing. So it doesn't seem like much to us today, but I think that was a new way of thinking of things. So Dr. Russell was the beginning of our tradition, and at the pinnacle of his career, he established the Coastal Studies Institute at LSU, which was then part of the School of Geoscience, which included petroleum engineering and other fields that wouldn't normally be considered part of the same unit at universities today. So it was a pretty big part of LSU because of his influence. And then Dr. S.A. Sue joined LSU in the early 1960s, and his book, Coastal Meteorology, is still being cited today. He was on my dissertation committee, and I'm going to show a picture of him in a bit, and he is still active. He sends me papers that he publishes. I think he's 90, and I got a paper from him a couple of weeks ago that he said, "You should read this, Bob," and I did. I sure should read it. We had a state climate office that was established in 1968 as part of the state climate programs in the other states, and it has been active for almost the entire time since the 60s. We were dormant shortly, and then thanks to Dr. Bushra and some other colleagues, we got it reinvigorated in 2024. So that's good. And then another thing that affected LSU's tradition in coastal meteorology was it's pretty innovative at the time, EarthScan Lab, that was run by Dr. Oscar Hugh for a while, who some of you may know, an oceanographer who interacted a lot with atmospheric scientists, and most recently by Dr. Nan Walker, who just retired last month. So the EarthScan Lab continues on. At its time, having available satellite image, we were among the first to do that, in the 90s. You don't usually think of Louisiana as being in the middle of everything, but in terms of the EarthScan Lab, they were able to get imagery from as far west as the West Coast to get California fires. They were able to pick up oil spills in the Gulf and in the Caribbean Basin, and deforestation effects in the Amazon, and all the way up to the Hudson Bay. So that was pretty innovative at the time. So LSU was a player in this development of the tools that we just take for granted today. And then for about 30 years, we had a regional climate center based at LSU. And most recently, Texas A&M was awarded the contract away from LSU during COVID. So we're trying to get it back, and we'll see. And then in 2017, I was asked to move from geography at LSU over to the College of the Coast and Environment, which is unique, we think, among colleges to have among universities, to have a whole college of the coast and environment or anything similar. And I was saying at one of my meetings a few minutes ago that I think the first major thing that I did was to get LSU into UCAR membership. So we did that, and our 8-year term just expired last year, and we were renewed. And if I'm still around in 2033, then I'll probably work on getting the renewal again. So it's been great to have your support and partnership, and it's really meant the world to us. So thank you. And you have to throw in a football stadium picture when you talk about LSU, but at least there's lightning here too, so it fits. And some would say that that's what it looks like for real in every game at LSU, but I don't know. That might go into myth. Speaking more specifically about coastal meteorology, you see our snowstorm that we had last year. That's real too. We had a graduate minor since 2018, but it has always been embedded in the Department of Oceanography and Coastal Sciences. So it's been more developed for oceanographers or forestry majors or other majors. It was easiest to get that going first before the undergraduate program got going. So we did that first. And regarding undergraduate education, we established a concentration in coastal meteorology within our unique, I keep using words like unique because that's LSU to us, our unique coastal environmental science Bachelor of Science degree program. So all coastal environmental science majors have to pick a concentration, and now coastal meteorology is one of 6. It was the third of the 6 to be established. So now we've got, environmental law and environmental health sciences and deltaic sciences, which is also unique. We're in Louisiana. And so we reestablished the Louisiana Office of State Climatology a couple of years ago, and we were able to bring back Dr. Bushra, who had done a postdoc in Massachusetts and had been a faculty member at the University of North Alabama. So some of our people are shown here on our diagram, on this slide. Dr. Miller just left us to go back home to the University of Georgia for him, but we've got new faculty member coming in August, and I think we'll be approved to get Dr. Miller's position replaced as soon as the new academic year starts. So we're going to miss Dr. Miller a lot, but we are also not going to stand still. So I think we'll be okay. We started a year ago, August 2025, in the first semester, we had 18 majors and we had 11 concentration students in coastal environmental science students with coastal meteorology concentration. So if you count them, we had 29 on the day we opened. And I think we're going to have 65 this August in about 8 weeks. And we promised when we did the proposal for the degree program to max out at about 50 after year 4. We promised 5 the first year and then 15 more, 15 more, 15 more till we got to 50. And if our numbers based on the acceptances and the people who paid deposits for the fall come through, we're going to have more than that on the first day of year 2. So I'm happy about that. Yes, and so our curriculum is fully Series 1340 compliant. And so our majors, we got faculty. Dr. Ross Dixon has been hired to replace Dr. Miller. And so along with Dr. Bushra, who's here with me today, Dr. Chunyan Lee is primarily a physical and dynamic oceanographer, but he's got a master's degree in atmospheric sciences, and he teaches classes in the coastal meteorology program. And Dr. Wengui Liang, who you see here, was just hired last year, and he's doing work on subseasonal to multi-seasonal precipitation variability, and particularly extreme precipitation in coastal environments. And I put Dr. Caparata's picture down here in the corner, if you can see it. He's the chief meteorologist at our CBS affiliate in Baton Rouge, and he's got a Ph.D. and degrees in atmospheric sciences as well. And I think he's the only person in the world, I think, somebody correct me if I'm wrong, who is a certified consulting meteorologist, a certified broadcast meteorologist, and a certified digital meteorologist. So the digital seal is new, so I don't know if anybody recently got one and now what I'm saying isn't true anymore. It's as true as far as I know it, so I'll say that. So Dr. Caparata teaches part-time for us, and we have 2 others who teach part-time in addition to the full-timers that you see here. Sydney Goldberg's an on-air meteorologist with a meteorology degree, and Dr. Nick Culligan teaches the hurricanes and typhoons class for us remotely, mostly remotely. And we have an academic advisor for our program too. So I'm really proud that, you know, LSU has stepped up. It's a pretty easy sell because I just tell people, is anybody here from Alaska? Okay, then I can say this, unless they're online, then they're going to get me. I think Louisiana is the U.S. state that has the most intricate relationship with weather and climate of any state. And so I ask LSU, why doesn't the flagship university have a degree program to invest in its people? Because we take federal money for disaster relief and we don't invest it in its people. I think NCAR and Coral Gables and other places should be full of people from Louisiana because we have the most to gain by making advances in modeling tropical systems, especially, and other weather systems. And I didn't get anybody arguing with me when I made the case. So it was a pretty easy case to make, but I applaud LSU for stepping up and funding this to this extent this fast. So I hope we don't let them down, and I rely on lots of support like y'all have already given us in our first year. And that brings me to this slide. It's a very happy slide. I would say that there were a few really big highlights in the first year, aside from the great student enrollment, which comes first always. And, you know, 3 of those highlights are directly because of NCAR and many of the people in this room and Dr. Bushra for setting up this series of workshops. And it really got our program on the map, so to speak, at LSU. And you see some photographs here. We started the year with the 20th anniversary commemoration of Katrina and Rita, 2005. That was the very first week of the semester. And so we did that and we honored Dr. Sue. It was one of my highlights of my career to honor him for all that he did to get us to this point. We've got a local AMS chapter that has remained active since 2018, except for a little downtime during COVID. And this is an example. We do a lot of video presentations. And this is Mr. Jake Swick, who is a consulting meteorologist out of Florida. Mr. Swick loves golf. And he was telling the students how you can get consulting gigs with golf courses when you can predict precipitation for irrigation and save them money. And the students really related very well to him. So we're going to have lots more of those. This is just one of the 3 presentations. I should have put more photos on another slide, but I thought this kind of told the story. This was our Katrina Rita symposium, and you see Jen at another of the workshops. There's another workshop. We had a booth at AMS in Houston, and so lots of people were like, meteorology at LSU? What are you talking about? So hopefully there'll be less and less of that as the years go on, and everybody will be like, yeah, LSU, meteorology, yeah. And so that's what we're hoping. I don't want to bog you down, but the curriculum is 1340 compliant. The things in red are the tweaks that we're making right now in the process. We want coding for our coastal meteorology students. We're developing more of a tiered curriculum now that we've got enough students. We had to be careful with that for so many years when it was mostly oceanographers. We couldn't have too many prerequisites. Now we're setting it up like a more conventional meteorology program. And so first 4 semesters are here, and you don't need to see everything on here, just to show you that thermo we taught for the first time last semester. We're moving thermo and dynamics. We had them in semesters 7 and 8 because we hadn't hired people to teach them yet. It bought us an extra year before the students would be needing the class. And now that we've got Dr. Dixon and Dr. Wengui Liang, we're in the process of moving those to semester 5 and 6, like most conventional meteorology program. The student has trouble, they can take it again, and it doesn't delay their graduation that way. And so the curriculum is evolving and it's developing fast. It's got lots of electives that are approved in other departments and that have a meteorology component. Again, the red ones are the ones that are being added or changed in some way to the curriculum. This agricultural meteorology class is new in agronomy. We got a new faculty member over there. And so we're establishing contacts with our colleagues around campus as well. Themes in the curriculum. Again, uniqueness is a theme that I've said a few times. And so many meteorology programs are attached to geography or other departmental curricula. Our tie, we're in Louisiana, so we got a lot of wetland, coastal, and air sea kinds of classes already, and that's where we're getting some of our students. We want to emphasize agricultural applications with that new class. We're in Cancer Alley along the lower Mississippi River. Cancer rates are as high as anywhere else in the country at that scale or higher. And so air quality, pollution, we don't have anybody yet, but that's on the list. We have air pollution environmental scientists who do classes like air pollution and society, but we don't have atmospheric scientists who specialize in that area. But maybe through future partnerships with UCAR, we can work things like that out, I hope. Tropics and subtropics, field methods. The field is very important at LSU in oceanography and coastal sciences, and we want to play to that strength that we already have. And then I put risk and resilience in bold because, in part, it leads into Dr. Friedland's presentation, but it also reminds us that in the new world of meteorology, where AI is so important, we need to think beyond forecasting tomorrow's temperature and precipitation and help our students by getting them to think in decision-making and certainty and uncertainty and risk and resilience in Louisiana. We've got to do better. We've got to do better. Some of Dr. Friedland's work with her students has shown that, and Rubai, Dr. Mostafitz in the back, suggests that by 2050, weather-related losses in Louisiana alone will be 5 billion with a B a year. We're a state with less than 5 million with an M. So that's $1,000 for every man, woman, and child every year lost in property alone and crops. That's not including the human loss, the loss in things you can put a dollar value on. You know, if we knock that down by 10%, that's $500 million a year. The whole state subsidy of LSU is $187 million a year. We could have 2.5 more LSUs with the money that we save. Now, if you're from Texas A&M, you might not like that. You might not want that. 2.5 more LSU. No. But the point remains, bridges, roads, schools, hospitals, infrastructure in other ways, it's terrible. It's a horrible loss. And so if we can put a dent in that, we're doing a really good thing. And that's what we hope to do. Decision-making, entrepreneurial meteorology is something that we'd like to look at. Maybe a certificate with the College of Business. Take 2 classes on how to run a business when you're not a business major and 2 meteorology classes, put them together. And we think it can help our students. And so with that, I thank you. And I guess we decided if there are any questions about this presentation.
I'm curious, what percentage of your students, do you have any idea which are Louisiana foreigners? Is that a state?
Thank you for asking that. Yes. So we have a common market in southern states where if you have a unique program that isn't offered in a student's home state, they can go to the unique program and pay in-state tuition. And so our Coastal Environmental Sciences degree program draws from Georgia a lot and other states as well, where they send their students to Louisiana. So the concentration students already have that. We're working on the coastal meteorology. They're trying to figure out if coastal meteorology as a major is unique enough from atmospheric sciences, and we haven't got an answer. So Georgia Tech, for example, has that. So I don't know if we're going to lose students from Georgia because they have an in-state program. That's just one example. There are other examples. But as of now, out of the students that I know, I think that I would say 30 to 40% are from out of state. And so it's a good question.
Yeah. They can speak personally for the issues, for sure.
Yes, yes.
Well, thank you very much for having me. I'm excited to talk about basically moving from earth science to building codes and how we get from information that we know to achieving resilience. And so I'm tying this in a little bit with the NCAR strategic plan, theme 1, building national resilience, and focusing on flood hazards today. So a report from Chubb shows that on the order of $735+ trillion in economic damage from floods since 2000. In the US, those estimates, and this includes some of the indirect losses that Bob was alluding to, between 200 and 500 billion annually. And in the Louisiana State Hazard Mitigation Plan. So again, this is just direct losses. This is not the indirect losses. We estimate 3.6 billion annually by the year 2050. So this is a state problem. It is a national problem. It is a global problem. And so how do we get from earth science to resilience? Here are the outcomes we want, where we're all sitting around high-fiving each other because our lives are great. We're not suffering from these flood events. And so looking at this continuum, basically from the meteorology to the hydrology to the hydraulics, and then, what is implemented in terms of decision-making in the U.S. are these flood maps. And so I realize a lot of earth science is even disconnected from these flood maps because those are regulatory products and other people make those. And then we have codes and standards and the actual buildings that are built. But why are we not all sitting around high-fiving each other? What is missing from this continuum? And I believe the answer to that is convergence research and the translation of that both ways, actually. So understanding why we're not getting the outcomes, what is happening with the buildings, what is missing from the codes and standards, being translated back to the earth science community, but then also pulling forward that knowledge that's coming from the earth science community that we can use to make those better. And again, I took this from the NCAR strategic plan, convergence research as a means for addressing complex, compelling problems in innovative ways by deeply integrating disparate areas of expertise. And I will say, this continuum, I don't think anyone works in this space, right? People are very firmly in some of these disciplinary areas. We can call them silos. And then when we get to codes and standards, the people that are implementing these regulations on the ground are very disconnected from the science. They are simply implementing what is in the code book, the contractors building the buildings, and then we have all of our people, our residents that are experiencing these outcomes, not always what we hope those to be. And so as I mentioned, flood maps, these are sort of produced by FEMA, part of the National Flood Insurance Program. And one of the problems in the US is that flood hazards and our experience of flood hazards have really been dictated by this federal insurance program. And that's not the way that we build for any other hazard. Typically, that is through an engineering consensus process. And so I like to tell people that once we understand the hazard, we need to figure out what to do with that information. So my presentation today is actually about ASCE 24, which is the American Society of Civil Engineers standard number 24. This edition was released in 24, so it's the 2424, which is a little bit confusing. But this is the National Technical Standard for Flood-Resistant Design and Construction. This is developed by the American Society of Civil Engineers following a ANSI accredited national standard consensus process. And so all of these national level standards basically need to have a balanced committee. So producers, consumers, general interest volunteers. I've served on this committee. I served on the 2014 standard, on this one, the 2024 standard, and I'm also a committee member for the next standard. So I'm not here representing ASCE. I would like to tell you sort of my experience, my perspective with this. And within this entire process, there's balloting. So people put forward a proposal. There are many reasons the ballot would not be accepted. People can make comments. They don't like the wording. They need to change the wording. They don't want sea level rise in it. And so all of these ballots need to pass with a 65% approval of the committee voting. And then there's also a chance for public comment. And so those public comments also have to be addressed before the standard can be released. And so there's a committee. I know it's very, very small to see here on this screen. The new committee actually has a lot of people. I'm not sure how many committee members there are on the new standard, but there is growing interest in this area. And committee membership is open. So you don't have to be a member of ASCE. If there are any, researchers here at NCAR, people online who are interested in participating in this process, learning more about how the science comes all the way to outcomes. This is a great exercise because you really learn how the sausage is made, and it's not always what you think it is. Now, within this standard, there's a lot of content. So things like flood-resistant materials, Chapter 5, dry flood proofing, wet flood proofing, equipment, utilities, access. The elevation standards are actually just in Chapter 1. So this was actually most of my contribution and sort of something that I've been working on since the 2014 standard came out. The reason for this is that we need those scholarly publications that we can go back and cite and say, this is why we're recommending certain aspects that are included in the standard. So before I tell you more about the standard, this was really a question that we asked in the committee as we started. And I'll tell you a little more why. But when we think about what level of outcome, right, that high-fiving at the end, do we want to see, it's really important to set that performance target. And so just in this room, we'll do a show of hands. How many of you think it's acceptable to flood 5% of your community's buildings over a 50-year period? You would like 5% to flood. You have to pick one of these numbers. 0, not allowed. Okay, quite a few. 10%. I want to flood 10% of my community. Okay, 20. Okay, pretty tough right here. 30%, 40%. Nobody wants to flood 40. You do. Tom does. Okay, good. Do not live in Tom's community. So just, mathematically rearranging these numbers, we can find if we want these level of outcomes, we know exactly what we need to build to. So again, this is not data, this is not research, just a different way of writing the math. And the problem is in the United States, we regulate to the 100-year flood. Everything we build, that's Tom's world. We want, right, design has an intention. Our expected outcome is that we would have 40% in these flood-prone areas to flood. And this has been the standard for decades. This is why we keep flooding so much. And so really a lot of people in here said 5%, 10%. That really is more along the lines of the expectation. So people have no idea what they should expect. They have no idea what they should get from these codes and standards. They just know that somebody else is handling it and it's going to be fine. All right, so now we're getting into the standard. I realize it's kind of maybe boring. You're like, oh, that's a big table. But this really is critically important. And so on the left side, we're showing what was in the 2014 standard. And we see 4 different flood design classes, 1, 2, 3, 4, basically agriculture, residential, community buildings, and critical facilities. And all of these have this BFE as the design basis. So the BFE is the base flood elevation. That's the 100-year flood. Now in 2014, we added this 1 foot. So before 2014, that 1 foot wasn't there. So build to the 100-year, that's good. That's Tom's 40%. So in 2014, we managed to get this 1 foot of extra protection, and then 2 feet for critical facilities or the 500-year flood. This applies to the state special flood hazard area or the flood zone, which is commonly called, although all zones are flood zones because if it can rain, it can flood. And that's the blue area if you ever look at a flood map. Now in the 2024 standard, we did something really important, and that's move to a return period basis. So we're still using the 100-year for agricultural buildings, but then for homes and businesses, the 500-year. So that's the 10% number over 50 years that many of you selected. For community buildings like schools, the 750-year return period, and for critical facilities, the 1,000-year return period. One of the reasons for this change is just to know what level of resilience or what level of risk we are facing in the community. That BFE +1, we have no idea how much protection that is affording us. And then another change is where this is applied. So this also applies into the 500-year flood zone because if we're only protecting the 100-year, well, at that 101-year, the probability is still like 40%, right, over the 50 years. So kind of this waterfall effect where people outside of the special flood hazard area are significantly underprotected. And so that was one of the changes that we made. So why are we moving to this? Kind of explained this, but basically it depends on your floodplain. So whether that's a coastal flooding area, a riverine flooding area, where you have very shallow floodplains, and the difference between the 100-year and the 500-year is maybe not that much because it has a large area to extend into. 1 foot of freeboard will buy you a lot of extra protection. But in these very steep floodplains where you have a rapid increase in terms of the level of flooding between the 100 and 500-year, 1 foot of freeboard buys you almost nothing, right? So you're still 35%, even though you think you're a little bit higher. And so really understanding a consistent level of protection across a community and then also within flood design classes. Now, something that we really haven't conceptualized yet within basically how we build is that risk is not equal. So we characterize sort of this flood depth return period relationship through the Gumbel distribution. And this point here, so the AEP, the annual exceedance probability for the 100-year event, that is the BFE, right? So that's the 100-year flood. And so all of these lines, would have the same depth. They would all have the same BFE. So right now we go into a flood map, we look at the value, and that's what we build to. But we understand that these different floodplains have different slopes of this risk curve, and that some places are subjected to higher risk and some places are subjected to lower risk. And so that's what building to a return period kind of gets us. I'm not going to go into this in detail, but basically for non-coastal, this is how those lines I showed on the last slide are implemented. And you can, so when I present this to floodplain managers, they say, oh, that's really complex. I'm presenting it to you, you say, oh, that's very simplistic, right? So it's a line, but basically every community has different levels of data availability. So some communities might have the flood elevations required for these mean recurrence intervals, and they can go ahead and use those depending what flood design class. Where they don't have these higher return period flood data elevations, this is just an estimation, an extrapolation between the 100 and 500 year event, or as we move down the methods in terms of what data you have available. Here in method D, these are basically just freeboard, I guess, placeholders in terms of what the average increase in flood elevation is over that 100 year when you have no other data available to know the slope of that hazard intensification. Now, coastal, approximately the same, but here we're dealing with still water elevations and coastal factors. And those coastal factors do depend on what those coastal flood sources are. But again, we're just estimating that line based on the information that we have. So we were successful in getting relative sea level change into the standard. It only applies for coastal flood sources. It's based on historic sea level rise and a minimum service life of 50 years. And so then our design flood elevation is either the flood elevation required by the community or the mean recurrence interval flood elevation plus that change in sea level, whichever one is higher. So this is sort of where things get interesting, and we start looking at what am I really talking about? When we looked at basically what is the difference between the previous standard and the new standard, and looking at sort of some averaged and pretty historic data from FEMA, so probability of elevation or PELV curves, we were able to look at basically the flood hazard characteristics that FEMA had previously categorized on a census tract basis and then map those across the country. And so the areas that are shaded in a darker color, those would be areas where the elevation standards would increase, or you can think of it as if our target is 10% flooding in 50 years, the darker shaded areas are unprotected based on that 1 foot of elevation. And so thank you to Rubai for making these maps. Then for flood design class 3, 750, we start to see some more patterns emerging. So basically, again, those darker areas would be traditionally underprotected from this 750-year event. And then as we look at critical infrastructure, so you might remember things like evacuating patients from hospitals a couple years ago, and I see basically the state of Kentucky emerging here. So literally, much of that state has been underprotected, is underprotected. They have no knowledge of this. They don't understand that 1 foot of freeboard that was implemented, or 2 feet of freeboard in this case, really hasn't been protecting them. And so we really feel that this standard will be, provide much more equitable protection across the country. So this is really being sort of pushed out by a number of outlets, Association of State Floodplain Managers. So most communities have a floodplain manager. Their professional association is the Association of State Floodplain Managers. And Chad Berginis, the executive director, said that this standard is the most significant update of floodplain management standards in over 50 years, basically since we started regulating through the NFIP in 1973. And so I see this as a great opportunity to sort of, see where we're at, look at what type of resilience we can achieve through this type of standard, and also where we're not really meeting the mark. So I think we talked about uncertainty in the last meeting. Certainly that's a big topic because these FEMA flood maps, you look on the map, there's a line, people think that's the 100-year. That's not the 100-year, right? That's the median value of the 100-year. And maybe that data product is 30 years old. And so what really do we need to really get into a situation where we might be meeting these targets that we want to? Now, I would like to say something about our scholarship. This is going to be very brief, but a lot of times people think that serving on these committees or doing this type of work is outreach, right? It's not real research, but we have, I think, about 19 papers in the past several years that underpin a lot of the information that went into the standard. So I'm showing some of these here and have a QR code if you want the full list of these. But really, we went from looking at one individual building. What is the risk to that building? How does it differ when you change where the damage initiation point starts? So does it start below the foundation? Does it start right at the floor level? How we can reduce some of this risk through nature-based features? What are some of the social impacts of these hazards? And so we've really been pushing getting these papers out so that we can cite them and use them as scientific evidence. One of the biggest important parts of this is understanding who pays and who benefits. So this is from National Institute of Building Sciences, and I know it has hurricane, wind, and earthquake, which sort of dominate the conversation. But these little bars in green down here shows who benefits from increased standards for riverine flooding. And that is the people who live in the homes, the tenants and the title holders. The developers benefit almost none. And so who do you think is at the code hearings? Who is talking about what the code will be for the country? The builders. Right? And so cost actually became the critical factor. This was the most highly debated topic. Thank goodness we had published this paper on cost and the differences in cost, a robust study, which they then, home builders countered, but we had something and could join that conversation. But really what I learned through this is my previous perspective was if we do better science, if we do more studies, if we know what the risk is, people will see and they'll make the right choice. But it always comes down to dollars. And so this is why we're looking at things like construction cost, life cycle cost, insurance cost, and also understanding that risk reduction is in people's mind not a real benefit. They don't see that in real dollars. They see the reduction in flood insurance premiums because that's a check that they pay maybe every month, or it comes out of their escrow every month if they have a mortgage. And so really understanding what are the questions that people are asking, what are the conversations centering around, and then being able to not only understand what they're saying, but then create knowledge and information that we can share to help other people understand that. So one of these sort of translation pieces that we also made, so those tables that had the line extrapolation equations, one of the comments we heard, that is too complicated, can't do it. Floodplain managers can't do it, building code officials can't do it. And so we made an online calculator. We didn't argue that it was too complicated or not, but this, removes the variables. It removes having to determine which method to use. You simply go through and answer the questions. You provide the information you have. For example, if you don't have the 500-year, it automatically moves to another method, and you don't necessarily even need to know that. So some of the key changes that we talked about, basically moving from a fixed freeboard to a return period or probability basis, extending that protection into the 500-year floodplain, and then having individualized methods based on community data availability. Now, really important is, so what? Who cares? What's going to happen next? We have this national standard. So just at the end of May, We passed the ICC International Code Council 2027 online government consensus vote. Basically, all of the building code officials in the country voted, and they voted to adopt the standard, both for the International Building Code, the International Residential Code, and also the International Existing Building Code. And so that still needs some final certification, but we are expecting that this new standard will be in the 2027 building codes. And then jurisdiction adoption is the next step. So then we can think, okay, we don't need to do anything. That's great. The jurisdictions will just do what they're supposed to do. So my experience, our experience with the 2014 standard, when we added that 1 foot of freeboard, Louisiana in 2018, when we were adopting the 2015 model codes, they stripped that out. They're like, we don't need that. We don't have a flood hazard problem in Louisiana. And so we didn't have that foot of freeboard statewide until 2023. So 8 years after it was in the national model codes, did we even implement the 1 foot? And so this jurisdiction adoption is extremely important because it depends what your community adopts. That's what gets built. And those are the people that we want to protect. So I'm running a little bit short on time. I just want to say a little bit about cooperative extension because we are part of the cooperative extension system, which is a national system that shares research-based knowledge across the U.S. So if any of you are familiar with like your county agent or you have some flowers and you can call them up and ask them questions, we're part of that system. Our emphasis is on housing, specifically resilient, sustainable, and healthy housing. The cooperative extension was established in 1914. There's almost a county agent in all approximately 3,000 counties nationwide. And so we conduct applied research, and our job is to get it out there. Our job, extension, is to create change. It's not just to provide information. We're also part of the Extension Disaster Education Network, which is a network across the country sharing this type of information about hazards and disasters. And Tom did mention that we were selected for the next cohort of the NCAR Innovator Project. So this is just our sort of organizing figure. But basically those national level maps, some of the limitations that I talked about, the census tract basis, the historic data, that's not really the best that we can do. And so working with NCAR, we really are looking to leverage the national water model to be able to look at the return period relationships for different areas of the country to get a better idea, do some of these return period depth relationships change based on river class? Are some of those changes regional? And so it will also give us a much finer result in terms of the mapping, which we can then share with our stakeholders as we move forward through this adoption process. So with that, I will end and appreciate any questions.
Yeah, Carol, thank you so much. Very interesting presentation. I'm just curious if there's any efforts going on the older construction, like any kind of retrofit or anything like this, because those new standards, they apply to new construction, but what happens with the older construction?
Great question. So the building code applies to both new construction and substantial damage or substantial improvement. And so we anticipate, right, as buildings become damaged, so that's by flood, by wind, by lightning, then the new building code applies, and those buildings would need to be brought up to the new code. So same thing for substantial improvement, and it can be a double-edged sword, right? So if you are, like, you want to buy a house, you want to renovate it and sell it, a lot of times if you're improving that more than 50% of the value, it falls under substantial improvement, and you would need to meet the new code. It is difficult for existing structures. It's a very difficult question. And potentially there's a lot of cost that will become sort of sunk into those buildings. But if we don't do something different, we will always have what we've always gotten. So.
You mentioned those developers are in sort of a different space, essentially, in their financial incentives. Is there any way or thought on how to sort of align incentives a little bit more and give them a reason to want to push for like meeting better standards And or do you have any developers that you're bringing in as part of the AgCenter or La House, like to make sure that they're intimately involved earlier on?
Mhm. So that's a really great question. And I mentioned this earlier, but one of the problems is when you sell a home, it's based on, comps, comparative value assessment. And so they're really comparing like square footages, numbers of bathrooms, finishes, and there's not anything in there for resilience. So this is a paper we're actually working on is for like solar generation equipment that you own as part of your home. So you're not necessarily paying the same amount for electricity. There is a green and energy efficient appraisal addendum, which is approved by the American Appraisal Institute. And so that actually you can opt to fill that out, and that gives extra value to your appraisal. So it provides extra value to your home. And so we're actually working on quantifying specifically for flood elevation, what that extra value is in terms of the resilience. We have talked with builders, and the thing is they don't want to finance national flood resilience, and probably they shouldn't, right? The owner is the one who benefits. In my opinion, the owner is the one who should pay. But because there is no mechanism to charge them, the builder ends up with the bill. And so we have talked with builders, and they seem very accepting of the idea that if they could get paid, they'd be happy to build it higher. It's just they don't want to sort of absorb those, unfunded mandates, as they call it. And so we do work with some builders that are, kind of more proactive, Energy Star, Fortified, building higher. I think a big problem in this flood space is we didn't know we weren't doing the right thing, right? So 100-year, that's what everybody knows. And nobody's really broken it down into, we still have a lot of flood risk. Floods are like, oh, it flooded, very surprising. And that's not really the reality. Thank you.
Kind of connected to previous question. I actually have two common questions. One is the insurance. And, clearly when you look at the 500 or 1,000-year, more area are under the impact, and that would increase their insurance. And at some level, like if it's a whole estate, the insurance company would not even insure them. So that is a conversation that makes it very, a hard topic to approach. So maybe if you can clarify like how you try to address that. And the second one, going back to your initial comment about the convergence, are there some efforts to bring engineers, to bring material scientists, to really put all the innovations so they can make the final cost cheaper? Because even if it's not a builder, for a low-income family who wants to rebuild, it's a lot of pressure if they also need to go through a more restrictive code. Mm-hmm. So how we can make it really equitable for anyone to really be encouraged to go for another license rather than thinking that I'm going to just build it and I'm not getting any license at this point. Mm-hmm. So I think those are kind of the societal impacts that really helps in the convergence study mm-hmm. to look into. So it's kind of general question on that.
So the insurance question is actually really important. And we had been funded from Louisiana Sea Grant. We kind of did this flood safe home project. And the original question was, how much more does it cost to build a home that's flood resilient? And what we found, the initial part of the project was during the previous sort of flood insurance premium calculation. And it was much more economically affordable to build higher because people would save so much on flood insurance. But during that project, we asked builders, what would it take to get you to build higher? They said, we'll never build higher. So then they implemented Risk Rating 2.0, the new premium pricing structure, which really raised a lot of insurance premiums to the point where it's unaffordable. And talking with people, so not necessarily builders, we said, what would you do? What would we need to do to get you to build higher? They said, we will do anything as long as you can reduce the cost of insurance. So you're 100% correct. Like the insurance cost is a very important part of this dynamic. The National Flood Insurance Program is actually not actuarially sound. It's more of a social benefit program. And so, they would have to get rid of the National Flood Insurance Program for flood insurance to not be available, but it isn't something that's, making ends meet at the federal level. For your second question, people have to want to change. That's all I can say. All of this standard committee work, is a volunteer basis. I know, construction industry, we use timber frame construction for homes in Louisiana. In Florida, they use masonry, right? So reinforced masonry, that's much more flood resilient. Trying to get that type of technology, which is not hard technology, but we've never built that way. We don't build that way here. And so there definitely is a resistance. I don't know, people don't want to buy a cinder block house, right? Some of the things that we've run into in Southwest Louisiana, people don't want an elevated house because they perceive that poor people live in elevated homes and they don't want their house to look like that. So there are a lot of factors, and also, I think moving the industry forward in this direction, architects, engineers, what does it look like? Accessibility issues, those are all issues that we need to tackle. But the first step, I think, is getting the homes, the buildings built higher. Okay.
Kind of related again, your sausage making comment, I would have thought that you'd have a lot of insurance representatives on the committee itself, because it seems like they would want to make sure they're not vulnerable. I can also see I could see potentially a lot of political pressure and you made a comment about, coastal changes in climate, but not necessarily riverine changes in climate being allowed into the most recent standards. So maybe this is an awkward question because we are recording this, but, I can see there's a lot of political issues there, and how you form that committee and how you come. And last but not least, do you use peer-reviewed literature almost exclusively for your guiding light? Or is there other documentation you rely on and things?
So I would say, so anybody can apply. ASCE makes the committee. They sort of need to look at that balance. If you're not a voting member, there's also associate member. You can also attend the meetings and not be a member. We also have like federal agencies, for example, that provide data. They participate in the discussions, but they're not necessarily, voting or anything like that. Let's see, the riverine, I think we don't have good methods for that, that we felt could be implemented into the standard. That's something that we're sort of looking on at in some of our projects. And then others on the committee are also very concerned about this future conditions for riverine hazards. Another thing, so Rose, our graduate student who's working on that innovator project, one of the things we just looked at is look at these flood insurance studies, write down the study date, maybe it's 1987, right? Then go and look in the water model. You have your discharges that's in this flood insurance study. What are the discharges that are in the national water model? Because 43 years ago, there's not even that much overlap now. And are the discharges that are reported in the flood insurance study, how do those relate to what is in the national water model? So I think there's a lot of opportunity to even understand from the date of the study to even now, is there some sort of factor we need to be putting on these values? Because really they're not even applicable anymore. Insurance, so we really haven't had insurance representation on the committee. I'm not sure what the reason is for that, but I definitely think as more private insurers sort of enter the market, they do have a definite interest in reducing the flood losses. So that's something we might see in the future. And I don't know, there's always sort of like this barrier between practice and insurance, that those two sort of don't mesh. I know on the wind hazard side, there's a lot more interaction with the insurance, and then also the IBHS, Insurance Institute for Business and Home Safety, with the fortified standard. So there, I think engineering and insurance have sort of merged to create a new standard. I think we have that model. Maybe that's something that would come out of it. So I hope I answered all those questions.
That's great. Yeah. I think any other quick last? I think we're a little over time, so maybe we'll wrap it up.